This is session 480, automatic detection of performance degradation and analysis as part of a CICD pipeline. So Kate and Petter, if you want to take it away, and I'll sit back and relax and enjoy it. Thank you.
Thank you very much, Stuart. So yes, welcome everybody. Thank you very much for joining our session today. And we are from Broadcom, from DevOps division on mainframe, and I'm a product manager of CA Mainframe Application Tuner. You can just call me Kate. And today with me, my co-presenter, my colleague, product owner of Mainframe Application Tuner, Petter Klomfar, who will be showing you the most interesting part today. So stay tuned. And without further ado, let's go to our agenda. Just very, very briefly, what we are going to talk about today is this concept of automatically detecting the performance degradation and analyzing the issue before performance issue before it gets to production. We call it checking or testing performance on every commit, on every application change. So I'll talk briefly about the reason, the concept of this, and the solution that we, for example, tried and constructed, and we can use it as an example using our product, but it can be for the same purpose, other product that you have. And then the second part, Petter will help us with a live demonstration, and hopefully crossing fingers that everything will work today and systems are up and running and network is perfect. So I'm going to have it on the real Zoe enabled continuous integration and continuous delivery pipeline. So, and then we will hopefully have a Q&A session, and we will welcome any questions that you may have. So let's jump further. And I think before we jump actually into the conversation about automated performance testing, I think it's essential to talk about current state of DevOps and how it applies to mainframe. So where does this demand for automating everything into the pipelines comes from? And apart from being an industry standard practice in the distributed world, in the non-mainframe world, it clearly has additional value for mainframe development and testing teams, and even for the production teams, but I'll talk about this later, about these benefits. So, and we all know, for example, that traditional development tools are not anymore all the time providing the desired user experience. For example, I'm talking about, of course, 3270 and ISPF-based tooling. And we know that even sometimes very experienced mainframers who are proficient with standard tooling are preparing for retirement, and sometimes new people are hired to replace them, which are coming from the, for example, universities with a distributed background. So now let's take some of the products which have Eclipse interfaces, and our product also has a elaborate Eclipse interfaces, and it's also sort of a standard for a subset of mainframe tools. And when we look at the studies, we see that actually right now it's also sort of not anymore considered modern by the very newcomers, because what they prefer in their daily life is something very flexible. So they prefer having API to a fat client. They prefer web IDEs. They prefer something that they can script in, something that they can quickly adjust to their particular needs, quickly automate, quickly script. So this is the mindset of the newcomers that come to the mainframe platform these days. So that is why we also considered going this way and actually enabling our product for Zoe, and that's how actually the whole Zoe idea originated. Um, so that's where we come to the idea of using open source tooling, and that is why open source tools actually become more and more popular, because you know, they are popular. The newcomers already have this knowledge, these skills, and these trends are actually affecting not only development, but also, according to the recent studies, they also affect the production systems. So there are not only developers who, for example, work in Visual Studio Code or Git, but there are also there is also new generation of sysprocs who prefer IDEs such as Visual Studio Code at their main environment, where they spend a lot of time. And actually, if we look at the businesses, the market, according to Gartner, 95% of the organizations leverage non-trivial open source software assets within their mission critical IT workloads, and whether they know about it or not. So, and it's this statistics is even from 2016, but this trend is clear, and you can imagine that these days the numbers are even higher. Um, yeah, that's exactly why we were looking at Zoe, and so but just before we start into talking about the solution here, so the potential the demonstration, before we actually talk how to include some mainframe product into the pipeline, I think it's just essential to understand what product we will be using for the demo today. And and today we're going to be using the CA mainframe application tuner. And just a bit of technical background so that everyone here understands what it is, this product is about. This is essentially a performance sampler, also with the automation component. And we will use it in this presentation to show how you can take such product and actually use it for testing. And we support, in terms of performance sampling, we support like over 20 subsystems and environments. And a number of programming languages, of course, including COBOL and PL1 and assembler and so on. We have extensive Java support. Actually, last year it was released a completely new Java agent and supports all sorts of Java workloads. So we have, which is important for our actually next demonstration, we have this automation component, which will play a key role in the overall pipeline. We integrate also with a number of other CA Broadcom solutions, but that's not the point of this conversation. The point of this conversation is how do you take a product like that, which you maybe you own some similar product, and how do you elevate your experience? How do you become more proactive? How do you take proactive approach to your performance? And how do you actually enable other teams in your shop, and development teams and testing teams to use this product? So let me jump forward. So just a few words about these different approaches to performance and how proactive you can be. And there are basically three types of three ways to approach application performance. And one of these, actually, I will read this slide kind of in the reverse order, so from right, because on the right we have the basic issue analysis after the fact it happens. So and unfortunately, well, from talking to our customers, from talking to our partners, we still know that a lot of shops actually do things like that. So they kind of wait till the issue happens, and then they try to fix it as quickly as possible. And for that reason, of course, and our product provides a lot of tooling and special applications, special views, and analysis of the data, and helps you find, and there are also, of course, other vendors' products for the same purpose. But then the next level of this is to be proactive in production. So actually anticipate that the problem is about to happen before it actually has a big impact on your production systems. So for that, we have, for example, this automation component, which analyzes on the fly your applications, able to learn it, and you know, alert you whenever something bad is about to happen, whenever the metrics of the particular, for example, bad job are about to are actually drastically violating the baseline. So that's one thing. And the next level, which we would like you know, to suggest and open this conversation, and this is a big emerging topic of, you know, actually being proactive in the testing environment and actually finding issues and before they hit production systems. So, and do not deploy this buggy code. So why is it important is because even if you are proactive in production, it's already great, and still you probably need to do all these things, because, you know, some of the issues may still anyways end up in production. There is always this chance, but even if you are proactive in production, you at this point it's everything is integrated. It's really hard and to find what was the issue about, so why it happens. When you do this on the level of development, you can easily track back the particular code change which caused this issue. So let's jump further back to the point of this whole presentation, and talk about the personas that are now in traditional mainframe application analysis, and explore the situation today. So, and we know that, as I said, a lot of, oh, I'm sorry, I think I need to go back one slide. So sorry. So nowadays, as I said, as unfortunately many people still are either not testing enough, or just being proactive in production, or even if they are performing tests, it's usually a pre-production level, integration level testing, where everything is integrated, and when you find the issue at this stage, it requires a long investigation by a very highly skilled specialist to find what the problem is. And of course, these specialists are usually hard to find. They're quite busy. They are in demand for their time, and so this creates a bottleneck. And the next bottleneck occurs when the production specialist needs to communicate back to the development team, and they have to discuss and find together a solution how to exactly to fix this on the code level. So that's another bottleneck. This leads to the situation when there is these bottlenecks which you don't know how to address. But it doesn't have to be this way, and many companies are kind of now realizing it, especially when performance tools such as MAT and other tools, they start to receive different interfaces, different ways to access them, and actually they provide a way for the development teams to actually address these issues, to be able to address these issues themselves. And according to the studies, if you try to identify issues earlier in the life cycle of the application, meaning during development, and test performance on every commit, and it means like on every application change, you do some portion of testing, or at least you check the performance metrics of the during your, for example, functional test. So if you do that, as compared to finding an issue in production, it can reduce the overall cost of the issue resolution by up to 64 times altogether. So let's progress here and talk a little more about the personas who can make all this happen. So here we are talking about the engineers and architects from DevOps departments, who would include performance testing into the automatic pipelines, automatic development process. And of course, the developers and QAs themselves who would actually execute these pipelines and perform the testing. And as I said today, they are a means to automatically detect performance degradation as part of CICD pipeline on mainframe. That's what we will be demoing in a minute. So, and modern open source automation solutions, such for example as Jenkins, you may have heard about it, they allow you, based on this detection, to notify the development teams immediately. And furthermore, mainframe analysis tools, like for example, CMAT, which we represent, but so they now receive also different interfaces, like for example, Zoe command line, and we will be showing this later. So, and this enables developers and development teams not only to be notified of the performance issue, but also allows them to do performance analysis using interfaces which are familiar to them, something that they already interacted with before. So if you compare what happens if you don't do automated performance testing as compared if you do it, so if you don't, of course, mainframe teams wait weeks before finding a performance issue, and it not only has business impact, but also required, as I said, a lot of time and effort from both production and development specialists. But what's interesting is actually if you don't do testing during development, if development teams don't care about performance, there's actually higher chances to introduce issue in the first place, because that is not the part of the team's mindset. So these days, the experts, if you run just the base Google search, you will find experts from Forrester, from Gartner, that they say that, you know, this needs to be part of the development team's mindset. And when you receive, after each change, when you know the particular change of the main metrics of your application, you will automatically educate the team, and you know they would be aware of the performance at the very minimum. And of course, the next thing is that they will be also notified about the issue. So when we talk about the actual notification and the realization, so now I come to the point of describing how we kind of tried it out and how we would like to introduce this. So we introduced this concept for our product, performance on commit, and we introduced it by means of new Zoe CLI extensions. We actually have two Zoe CLI extensions, and one is for DevOps engineers and architects, for someone like Ravi here on the left, who is actually including the performance check into the pipeline. And the pipeline is basically just an automated, cycle of changing the code, building application, deploying application, running a test, checking against the baseline. That's where checking against the baseline happens by means of exploiting this CLI extension. So you can retrieve the base performance metrics. You can also retrieve automatically any alerts that the underlying component, which is checking the performance, has raised. So, and this underlying component is actually PMA, which I mentioned before. So you would run it, for example, on a testing system, and it would provide the data for this plugin, for this CLI extension. And then you can script it in, and upon any alert that you retrieve automatically, you can automatically as well in Jenkins or other automation solution, you would send an email to the development teams. For example, this is one way of communicating that something happened. And in our case, so that's where, Michelle, and that's how we call our developer persona, she would receive an email notification that something has happened. And that's where the second plugin actually starts to play. And the second plugin is to CMAT Analyze, is for actually analyzing what is happening. So now you are notified of the issue, and now you can jump into the analysis of the issue. The good thing about all this is that they are actually working together. So whenever the MET detects an issue, it automatically creates a measurement underneath, and then Michelle doesn't need to rerun the test itself. She can just start the analyzing, having the analysis, having the data from the time the issue happened. But that was, a lot of words. So I believe you all would prefer to look at this at the real example, and here Peter will help us and demonstrate this in the live CI/CD pipeline. So Peter, please take it over.
Yes, taking the screen sharing here. So just confirm me that you can see the start of my presentation.
I can.
Yes, I will have just a few slides. Thank you for handing over, Kate, and everybody welcome. It's absolute pleasure to have you here on our session today. So I will walk you through our current implementation of the functionality that Kate was just describing. So let's start with small prelude with a diagram how the implementation is being handled, and then I will take you live on the action, and I will show you the pipeline in Jenkins and everything. So here is the pipeline itself. As Kate mentioned before, we are starting from the point of view of a modern developer. In our case, it's Michelle. Michelle is our representative of a modern developer, and she's making a change in ID of her choice. In our case, it will be updating an element within the Visual Studio Code. And whenever the Visual Studio Code is updated, I will save the change, stage the change, commit it to a GitHub repository, and afterwards push it to a backend to an Endeavor. The push to Endeavor, to our source code manager on a mainframe, will be done through another component which is playing a role in our DevOps pipeline, which is Endeavor's enterprise Git bridge solution. And that will transfer the change from my GitHub into a backend. When I have the change on the backend, I still need to trigger my pipeline. And for that, we have another element playing a role here, which is a webhook server. A webhook server can do a certain actions upon different actions that you may register. In our case, it will be update action, but you may have any generate in place, moving from the development stage to QA stage, moving to production, and so on and so on. In our case, as I just said, it will be an update action. That will trigger our Jenkins pipeline. That's the orchestration that we have on the background. And that's exactly where one of the components of performance of commit comes into play. The CMAT detect, which is being backed up by PMA, that's Performance Management Assistant. And already at this stage, Michelle can utilize some of the commands like get performance or get alerts. But since this is automated pipeline, we want to have it most convenient for her and easy to use. We are providing emailing reports. The email report may have multiple stages from initial email, and I will show you during the live presentation, throughout the normal range up to the alert. And we will be focusing today mainly on demonstrating the alert, the dreadful situation when the performance degradation happens. So Michelle will receive similar email like this, and I will walk you through the details during the demonstration. And at this stage, she knows that something went wrong, but she still wants to dig deeper to actually determine what is the root cause of the performance degradation, any of the code change she introduced. So for that, she can utilize the second component, CMAT Analyze, that is being backed up by mainframe application tuner, and utilize our CLIs to retrieve from our CMAT database the necessities of the information. Already at this stage, since we received an alert, CMAT Analyze automatically triggered a mainframe measurement for the test or job under test, I should say. So she has multiple commands she can utilize, and again, I will go one by one throughout the presentation. So let me just glance through them from the overview throughout the historic measurements of the individual pipeline triggers from the code view, drilling down to the specifics of the modules that are being attributed to the activity or the delays. It will be better if I will show you live. So let me very quickly switch to my Visual Studio Code. And I will be doing the changes on behalf of Michelle. Here you can see one of our COBOL programs. It's a batch COBOL program. It's for installation verification purposes for our product. And we are using it for demonstration purposes. And on behalf of Michelle, I will, for example, ramp up this perform subscript. But bear in mind that Michelle, during work on her application, she can do multiple changes at once. She can do coding of new functionalities. She can even try to resolve some defects or some bugs that might have reported for her. And for this specific demonstration, the scenario is simplified, but there are literally no limitations. So when I have done the change on behalf of Michelle, as I said, I will save the code. I will stage it. As soon as I will stage it, I will commit it to my GitHub. Demo for GSC UK. And of course, I need to push it as well. So push. Oh yeah, passphrase. So security first. And now I will walk you through of the pipeline execution. If I'm gonna switch here, upon refreshing, I should see that the GitHub, or sorry, Git repo has registered my change. And I should see here in the Jenkins pipeline, a pipeline trigger in any seconds. On the left, you can see that the pipeline is already in the pending stage. And whenever it starts executing, I will walk you through the blue ocean because it's more digestible for viewers. So let me click on the pipeline, which is executing. And let me show you as soon as it loads the insights. So our pipeline is consisting of multiple steps. We are starting with something called run autogen compilation job. This is for maintaining the stability of the testing results. So basically, whenever she made the code change, within the source code manager, we need to make sure that it's being properly generated and there are no syntax error, meaning that the application can be executed. So for that, we are utilizing some ZOSMF submit commands for this specific pipeline member for autogen. Then a test under or job under test is being submitted to a mainframe processing. You can see that the demo CICD program is being run. Already at this stage, PMA, or I should say CMAT detect component on the background has collected the data into our KSDS cluster files. Those are vsum files, and we are collecting the SMF records subtype 4s. And we can also get the information from them from the KSDS job file. about the individual executions, or we can check for any alerts that may have happened during the significant breach of the, or I should say, significant performance degradation. And at the end, the last step is where we are producing the emailing report for Michelle for her convenience. In the meantime, you might have noticed that at the bottom, I have received an email notification. So maybe let me walk you through the ones first before I show the new one. So as I said, multiple emails may happen. Within the start of the pipeline, we need to set up the baseline to actually have some calculations possible. So the first email she would receive whenever she would submit the application, she would receive this initial test one. Not too interesting. Then throughout multiple runs, she would have established the baseline and she would start to feel and see the calculations. This is how the majority of the emails look like. Overall status is within the normal range. And on the email, we are actually showing multiple tiles. As you can see, for CPU deviation, elapsed deviation, XCP deviation, or IOs, or service units. Those key performance indicators, or KPIs, if you wish, are reflecting the current run of the application, respectively, they are counted towards the average value baseline. And also within those email information, we provide information about current run, when it was submitted, what time, on what subsystem or LPAR it was running, and what are the main metrics that we are observing. We are directly comparing it with the previous run, so you can have the comparison. And we are showing also the average values, inclusive of the job details and the environmental variables. Now let's focus on the demonstration of the dreadful situation. So if I show, as you can see, the email that I have just received from my pipeline is overall status alert. No longer we have those nice green tiles, which were bright blue under the sky and everything was happening within the margins that we have expected. We can see that the change that I have done within the, or Michelle have done on the Visual Studio Code has mixed up the values quite a bit. We have seen a significant deviation for CPU as well as elapsed time, as well as for service units. The remainder of the emails is pretty much the same, but again, for her convenience, whenever she decides to dig deeper into the root cause analysis, we are providing the Zoe commands for her within the same email report. So she can take these and she can just open conveniently the terminal on her Visual Studio Code or IDE of her choice, and she can start drilling. Let me just delete this command. I wanted to paste different one. Let's start from the high level. If we issue Zoe MAT monitor overview for profile demo CICD, we should be receiving an overview information about the job under test. The information within the terminal is now showing the environmental variables. It shows how many observations we have used, what amount of the observations were targeted as an activity of the program, what percentage was targeted as a delays or as a waits of the programs. And from that, it gives me the high-level overview. However, I still need to dig deeper and understand what is the change, what is the stuff in the code that has caused this havoc, if I may say. So if I just go, let me maybe one more step backwards. I was mentioning also that you can take a look on the history. So if you list the history using Zoe MAT monitor history for profile demo CICD, you will see the hit from the database for each of these executions that we have listed. And you can see that the latest one with monitor number 50 is the one that we are displaying. So whenever I'm using a Zoe CLI command with simple profile without any monitor number, I'm receiving the latest and the greatest of the measurements. However, just for demonstration, I can show you that if I would fetch the information for monitor with monitor number 8, it would bring me this 4th of November measurement. And you can simply do the comparison even from the CA line point of view. Nevertheless, let's get back on the business. We will start from endpoint, which is called code view. So whenever Michelle issues Zoe MAT monitor code view for CSEC profile demo CICD, she should be receiving information about so-called code view. And here within this code view measurement, you can see individual modules and CSECs. And if we know within the database the descriptors or high-level descriptors for each individual modules we are providing as well. And she can easily see that the demo cop B1, that's the application that we were just running, from the performance monitoring perspective, was the heaviest hitter. 51% of the activity was attributed to this specific application code, and 25% of the delays or the waits have been attributed to this application code. But I still need to go deeper. I still need to understand fine, I know the application was the culprit. I know that my code change has caused the performance degradation, but what exactly has been the issue here? So for that, we can do one level even lower. So if you do a histogram for code view, so we are basically going one sub-level from the code view itself for this histogram view for this specific profile that's given, and we are targeting module and CSEC for demo cop B1, which is a representation of this line. I'm using also top 20 scope because it will simply allow me to easily and nicely sort the information with the highest activity at the top. Without that, it will be a normalized histogram, and you will see it probably somewhere in the middle. With having the program registered and the listing available within our database, Michelle can receive the information very easily about which particular statement is being the heaviest hitter. And in our case, it's statement 141, which is at verb. And these are the activities and weights attributed to that. And again, very conveniently, without any need from Michelle pulling up the listing or having any other subsequent steps, she can correlate this information. Let me just move a bit. This statement 141 as an add, I can simply refer to my editor screen and slide down to statement 141. 141 is this specific add instruction. And it's part of the label for subscript minus 100 or subscript 2 minus 100. And if I just take a look from the coding perspective, what is this label doing? It's the perform that I have just changed. So this is the easiest tieback, seeing and providing the information what my code change have done within the application, where the heavy hitters has been shown. And from that, I can, as a developer, start to think about, could I have did I make any mistake? Could I have coded differently? Could I have used the different instructions to perhaps stick to the SLAs or shrink down the execution and the cost for the application run? So this is basically the culprit identification. But our Zoe commands, and bear in mind they are constantly evolving, and we are bringing more commands and more views into the pool, which other users of the ISPF would be used to. We can also provide different contexts. So for example, we can also take a hit on the wrong line. My apologies, wrong cursor placement. So if I go back to the terminal, just slide it a bit, and if I do the code view for caller ID. So from the same code view screen, I'm now doing a different sub-level, different endpoint, and maybe let me correlate a bit. Again, I'm looking at this IGZ CPEC system routine with the IGZ CIN1. And if I do it, I should be seeing hit that the caller ID for our demo COBOL program was actually hitting at statements 152 and 161. And again, very quickly and very briefly, I can do 152, which is this inspect, as well as 161, which is this inspect. So I directly know either from the offset and the listing or from the statement within the CLI. In my editor, I know that within this specific line, this specific IGCCN system routine was called from within our application. And allow me a few more commands before I will hand over back. We can also have a different contextual views. So this was the code view. This was the code view where we was trying to attribute the performance degradation for the specific statements. But we can also display, for example, the delay view. And within the delay view, we are more interested about the delays. So I can list even for the program active and program or major and minor category for program active, I can list down the gradual specification. And in this case, I don't have the registration tied back to it, but if I take a look on the heaviest hitters here, and let me just make it larger again. So for example, this specific 9 delta 2 in the offset from the listing is the heaviest hitter. You can either refer to the listing yourself, and you can even utilize another components, for example, bringing from the source code manager itself, the listing immediately. And if I do so, and I do search for, oops, it was 9 delta 2, if I'm not mistaken. 9 delta 2 is part of, because this is a COBOL program, again, this is part of the one instruction for COBOL. It's at statement 141, no surprise here, and it's part of the subscript. So again, differently, it ties me back to the specific parts of the program that has been changed. I wonder if I have anything else that I would like to show you. Probably not at this stage. Let me get back to my presentation, and let me go to, oops, my apologies, just very quickly. I want to go here, all right. So basically, this is the presentation of those two components involved within the performance of commit functionality, and this is how you can utilize them. The easiest way for you is actually obtain them and try them, or if you are not a customer for our product, don't worry to reach out to us. Not even about these components, but engaging with us for the conversation in regards of performance tuning, sharing your experience, it's always very welcome. So we will be happy if you would reach out to either me as a product owner or Kate as a product manager for mainframe application tuner, or our architect Tofik Cemal Ahmed. And two more things that I would like to mention on this slide. It's very easy to download the certified plugins for npm.js site, and basically looks like this. You can filter for at Broadcom and just see the plugins themselves, see how they are performing, see the descriptions of the plugins if you would like to get more information. Or you can even utilize our TechDocs platform where we have CICD pipeline guide. This pipeline guide allows you to not only implement the functionality that I was just showing and we were highlighting with Kate throughout this presentation, but we also share the tips and guide how to actually set up a DevOps CI/CD pipeline in general. So feel free to refer to your materials and take a look on the documentation itself if you would be interested. And last two slides from my side, your session feed or your session. My apologies. Your feedback on our session is quite important. We would be very happy, and I believe I only have this this reference wrong. Stuart, can you give me the session ID, please? Do you remember?
One moment.
It's 480.
480. Yeah. So my apologies. I have a little bit of. Let me do it very quickly. 480. So you can utilize these QR codes for your convenience, and or go through the URL and provide a session feedback for us. It will be most welcome. Please do so if you have a chance. Also, you are probably aware by now that the GSC traditionally provides a charity, right? So consider yourself showing an appreciation and kindly donate a small sum to a charity this year. Either from perspective of our presentation or from any other content that GAC has shown throughout the conference. And again, for your convenience, you can use the QR codes within your materials, and you can simply click through the URL provided on the screen. Well, with that, thanks on my side. And if you would have any questions, we are here for you and we will be glad to answer them.
I'd like to say thanks. Kate, did you let someone into the room because I was so engrossed in the presentation, I wasn't looking at the participant slide. So that was really interesting.
Thank you so much. I didn't realize. I didn't know if you were you should do it or I, but that was just better admit people than not, right?
Absolutely, no, and I found that fascinating, Petty, your demonstration of being able to interact with Matt on the mainframe and being able to bring the measurements into your IDE. That's really interesting. There really are no excuses, are there, for people not to do performance measurement earlier in the life cycle of the code?
And for sure, this is in everybody's interest, not only the corporate you are working on in terms of the cost for the application running, but even from the defect count reduction, as Kate mentioned. So everything ties together, and performance tuning is a no-brainer to be part of your daily operations, I think.
Indeed. So anybody on the call, if you have any questions, please type them into the chat, and Kate or Petter will be happy to answer. And to remind you, the session was 4AT for feedback. That's really important, please. 4AT. I'll give it a couple more minutes, see if there is anyone got any chat. And of course, do you have the slide with your contact details again to show, so that if anyone wanted to follow up?
Sure,
indeed.
Absolutely. Yeah, in fact, the QR codes and everything was uploaded, the correct version is just a lingering one from our previous session. Yeah, feel free. I think this is like so kind of a new way to approach things, and I would sincerely welcome any kind of feedback from any company, and not necessarily if you're not a Matt customer, doesn't matter, because we really would like to hear about your experience, and would you find something like that to be useful? Would you what obstacles do you see? Would you see how useful that is? What is the persona you would in your shop you would suggest this for immediate implementation? So feel free to reach out, and if you have right now just feedback, if you find this concept in general useful to you, just I would sincerely appreciate if you just type it in the chat, or if you think this is something that can be part of your development cycle or of your testing procedures. But in any case, feel free again to just give us a note, and we will be really glad to talk to any kind of DevOps practitioner. They're interested especially in the performance testing, or in fact in any automated testing.
Okay, thank you. So the video, as I say, will go onto the GSE YouTube channel sometime in the near future. So thank you, Kate. Thank you, Petter. I'll end the call now.
Thank you very much.
See you soon. Cheers. Bye-bye.
Thank you. Bye-bye.
Thanks, everybody.
Have a great day.
Thanks,